All right, kids, you're going to get the doodle on my phone on the couch with child and Encanto version of a review today because it turns out that we can't just have a day off. We also have to have a day off with a ear infection. So, get your reviews. Here we go. Number one, we talked about classifying terms, and most of y'all like this. It's just look at your notes and double check stuff. Hey, you settle down over there. Look at your notes, check out your stuff. If we're talking about by number of terms, how to classify something, remember that was, is it monomial, binomial, trinomial? And then after that, we just kind of give up. 4 terms and more, we call it a polynomial. So you look at this thing has 4 terms, none of them can be combined. So I say it is a polynomial. Yes, my handwriting is worse on a phone. If I'm going by degree, remember you're looking at the exponent of each. So you have 5, 4, 1, and 7. Well, I know. Okay. The 7 is the biggest exponent there, so I would just say it's a degree 7. And that's it. It's a polynomial of degree 7. For B, notice that I only have 1 term. Even though there's a bunch of stuff smashed together, it's still 1 term. There's no pluses or minuses separating out different terms. So 1 term is a monomial, and the degree is 3. Now remember that when I had a degree that was special, basically 0 through 5, that they gave special names. He's over here playing with his shakies and just going to town here if you hear my kid in the background. We had degree 0 was a constant, degree 1 is a linear, 2 is a quadratic, and 3 is a cubic. So even though you could say it's a monomial of degree 3, we're going to say it's a monomial cubic or cubic monomial because it's special. Okay, so let's get rid of all this. There's got to be a faster way to just clear everything out. Okay, so I'm going to back that up, then we'll go to the next one and we say, I want to draw on this one too. Oh, I can draw on it with my screen recorder. Cool. It's a new phone, new app. Simplifying expressions. This was all about, am I going to add or multiply or divide or subtract? Well, we didn't do divide. If I want to, come on. There we go. There we go. I'm actually going to start with B because it's addition. See, there's nothing here to distribute, including no negative signs. So I would just write there's 5x squared minus 9y squared minus 3x squared plus 5xy minus 8y squared. Notice that when I said plus a negative 3x, I just kept it as minus 3x. So everywhere that there's a plus or a minus, we chop it up. And we draw our little box and we say, are there any other x squareds? Yes, there are. They're right here. So we'll say 5 things minus 3 things is 2 things. Remember that the exponents will not change. And then I'll scribble them out so that I don't use them again. Are there any other y squareds? Yep, there's negative 9 of them and negative 8 of them. Altogether makes negative 17 of them. And I'll scribble it out to not accidentally use them again. And this guy, I believe that would be Gavin, is just there all alone. So I'm going to put 5xy. Okay, and that's it. Now I put it in this order because it has to do with how I multiply out binomials. We actually are used to putting our x and y singular squared terms on the outside. We'll deal more with that as we get into the binomials. Okay, so we'll get rid of all this. There's got to be an easier way to do that. There's gotta be an easier way to do that. Oh, wow, it won't even let me erase it. All right, well, that's all right. We'll go over here. Now, notice that I have that -1 in play. Now, I could say 7x minus a 3x. I could say nothing minus a -x squared. I could say 1 minus a -5. Oh, here comes Baby Bear crawling on my lap. But so many of us, I know, dude. So many of us preferred to instead distribute this and then just use our box method from the previous problem. So I'll say that's -1 times a -x squared is a positive x squared. -1 times a 3x is a minus 3x. -1 times a -5 is a positive 5x. And chop it up. And you ask, first I'm actually going to start with x squared because it's the big dog, it's the biggest exponent in there. No other x squareds, all alone. And then, are there any other x's? Well, there's more than one this time. I'm going to have, I put an accidental x there because a kid was crawling on me. 7x minus 3x is plus 4x. Scribble them out. All done with those. Any other constants? Yep, 1 plus 5 is 6. So simplifying the expressions are just combining like terms, making sure not to change the exponents as we add and subtract, and making sure that if we ever subtract an entire thing, I'm going to distribute. All right, on to number 3. This time, we're talking about, can you multiply? Oh, get over here. There we go. And so many of you had different flavors about what kind you liked for this. Some of us preferred the box method, where we would plug in there 2x plus 5, x minus 4, kind of like your Punnett squares in biology, and say 2x times x is 2x squared, a 5 times an x is a 5x, a 2x times a -4 is a -8x, and a 5 times a -4 is a -20. Cool thing about doing it this way is that my like terms will always be on the diagonal, and I will write 2x squared minus 3x minus 20. So that's one way. The other way is I could instead, there we go, just first 2x squared outer minus 8x inner plus 5x, and last, multiply. That was our FOIL method. Again, if you have like terms, make sure you put them together. Like so. Okay, so whether you do box method or FOIL or draw your little rainbow arrows or stack multiplication old school, I don't really care. You're going to get it. Okay? Number 4 was the same, but now you're going to have to deal with those exponents. Remember, exponents have different laws. With an exponent, if I take 5x squared y times 3x cubed, what you kind of want to do is match like parts. 5 times 3 is 15. X squared times x cubed, if you remember your rules, okay, cue Kevin with his cards, you would add the exponent. So now it's x to the 5th. And then y to the 1st times no other y's, he wants to play with a balloon, is just y. And because I think it'll be funny for you to hear this, there goes the balloon. Then I'm just going to keep that party going. I'm going to take 5x squared y times the next guy, making sure that I have a -7 with it. A 5 times a -7 is a -35. An x squared times an x, add the exponents, is x cubed. A y to the 1st and a y to the 4th, add the exponents, is y to the 5th. And then one more time, take that thing and distribute it to 4y. The 5 times the 4, positive 4, is plus 20. X squared is just x squared because there's no other x's to multiply it with. And y to the first times y to the first is y squared. Okay. Okay, he's laughing like a maniac because he thinks these balloons are awesome. Here you go, dude. All right. So those are the new ones that we dealt with, section 4.1 through 4.3. Our last two problems are going to be, we need to review. It's been old times since we had a little bit of exponent action. So, first things first, you look at them in parts. 60 and 36 are regular old numbers. So I'm going to reduce them like regular numbers. 60 divided by 6 is 10. 36 divided by 6 is 6. Really distracted right now. And you always want to keep going if at all possible. 10 is divisible by 2, and 6 is divisible by 2. So I could have instead divided both of those by 12. The idea is I don't care how you do it as long as you get to the most reduced answer. When you move over to your x's, the rule for exponent divided by exponent was to subtract. So negative 5 minus 3 is negative 8. And we remember that there's a rule that says I put that downstairs. Right? You're too negative. Go downstairs. I also have a y squared over y. Again, I can take 2 minus 1 to get just y. Or another way to simplify those is the who's got more game. You say there is one more y upstairs, so y to the first. Now, when you put all of that together, you see a 5 up top, a y up top, a 3 down low, and an x to the 8th down low. And they are all still getting that third. So now I need to apply the third power to all of them. So I'll say 5 to the third. Remember, use your calculator. It should be an x to the y button, maybe a box to the box button, maybe the caret button, if you don't remember off the top of your head, or if you don't want to take 5 times 5 times 5. But 5 to the third is 125. 1 times 3 means y to the third. 3 to the third is 27. And exponent to an exponent, 8 times 3 is x to the 24th. You hear him doing his little brrr thing. He wants more balloon. So, we'll get rid of that. Coolest thing in the world. And our last one was, can you solve and graph inequalities like we did back in first semester? Stage 1, as always, disturbert. I'm going to take 7 times both of these, getting 35 minus 14x. And then you put the Paxton line so no one else is mad about it. You play the Who's Lonely game. Yes, I know, I'll do another one. And that 14 is lonely, so I'll subtract 35 from both sides. 0 out. And get my negative 14x is greater than a negative 49. I finish it off by dividing. Divide by negative 14. Divide by negative 14. Get x. I divided by a negative. Remember that rule? Multiply or divide by a negative. You have to switch your inequality. And the negatives cancel out. 49 over 14. It doesn't come out cleanly, but both divisible by 7 turns into 7 halves. Now, it does say solve and graph, so again, we're reviewing a bunch of stuff. That final ain't too far away. I'm going to put a 7 halves on my number line because it's not equal to. Less ink here means less ink here. I'll have an open circle and see how it's a little arrow pointing to the left. X is less than, so I will go to the left. So there you go. That's the short version, highly distractible version of your review. And sorry it's so late, but pharmacy left me driving around town waiting on a prescription for about 2 hours this morning. So last minute it is. Get your test, open notes, open everything. Best of luck. And yeah, see y'all Monday.